So let's go over the review for exam number 1. And we're just going to go over specific questions like number 2. Number 2 says, based on the graph above, estimate to one decimal place the average rate of change from x equals 1 to x equals 4. This is a simple question, so we don't want to miss it. The average rate of change means the slope of the secant line from x equals 1 to x equals 4. So sometimes the graph does not pass through the grid. So like in this case, it's a little bit above 2. And at x equals 4, it's a little bit below 4. So, I mean, you can round. If you put 1, 2 and 4, 4, that's also okay. But in this case, I'm going to say it's 1, 2.1. This one, this point. And this point is 4, 3.9. And so that creates this secant line, and we want to find the slope of that secant line. This goes back to algebra. The slope of the secant line, so in this case, I'm going to say the average rate of change is equals to y2 minus y1 over x2 minus x1. So label the points. This is x1, y1, x2, y2. So we get 3.9 minus 2.1 divided by 4 minus 1 is 1.8 divided by 3, and that is 0.6. So the average rate of change from 1 to 4 is 0.6. The graph below is the function f of x. Find the following. If no value exists, enter DNE. So all of these limits focus on -3. So we're going to focus on this portion of the graph. Sometimes we need to find limits as we approach different x values. That it's also okay, but in this case, it only focuses on -3. So the first one says, the limit of the function as x approaches -3 from the left side. So as we come in from the left side, let's look at what happens to the graph. The graph is approaching -3. The limit as x approaches -3 from the right. So as we approach -3 from the right, the graph is approaching 3. The limit of the function as x approaches -3. So as x approaches -3, it has to be the same value coming from the left and coming from the right. But since these two are not matching, then we say this is DNE. And then the next one is not asking for limits. It's just asking for f of -3. What is the y value when x is -3? So for that, we're looking at the closed circle. And in this case, the y value is -1. Assume that instead of f of -3, it was asking for f of 2. F of 2, so this is x equals 2. We're looking at this value over here. So that looks like it's about -3.5. So you would say f of 2 is -3.5. Number 4, this is a piecewise function. This is the domain for the first formula, meaning this is the first formula, and this is the domain for the second formula, which is this one. So think of a number line. This is 5. Because it has the equal to, it means that the 5 is included, and we're using these values. The second domain, it says x is greater than 5, so at 5, we put an open circle because the 5 is not included, and we go this way. The first one says, find the limit of the function as x approaches 5 from the left. So which one is coming from the left side? This one is coming from the left side, so it means that we're going to be using the first formula for the first one. The second one says, find the limit of the function as x approaches 5 from the right side. So which one is coming from the right side? This one. This is coming from the right side, so it means that we're going to be using this formula. And then the last one, it's asking to find the limit of the function as x approaches 5. So if the limit for the one in yellow and the one in blue are matching, then that's the limit as x approaches 5. But if it's not matching, then we put D and E. The first thing that I told students is apply direct substitution. If we get a real number, then that's your answer. But if we get something weird like 0 over 0, then we need to do something else. So the first one, I'm just going to use the first formula, and wherever I see it, I'm going to plug in 5. And that is negative 26. For the second limit in blue, I'm going to use the second formula. So wherever I see it, I'm going to replace it with a 5. And that is 1. Since these two limits are not matching, then we say that the limit as x approaches 5 does not exist. Number 5, the graph below is the function f of x. Find the limit of the function as x approaches 2 from the left, as x approaches 2 from the right, as x approaches 2, and what is f of 2. So in this case, again, we're focusing on a single number, which is 2. So let's think of this vertical line here. As we approach x equals 2 from the left side, so as we come from this side, the graph is going to positive infinity. As we approach 2 from the right side, the graph is going down to negative infinity. The limit of the function as x approaches 2 does not exist because those two are not matching. What is f of 2? In this case, f of 2 does not exist because we have a vertical asymptote. The only way that f of 2 is an answer is if you see a closed circle somewhere there in the graph. So that's the only way that you have an answer. But other than that, we would say D and E because we have that asymptote there. Question number 6 is a little bit different because so far we have found limits as we approach a single x value. As we go closer and closer to that specific x value, this one is asking what is happening to the graph as we go this way. So in this case, as we go to the negative infinities. So as we go this way, what is the graph doing? The graph is approaching this value, which is 4. By the way, when it's asking to find the limit, this here, the limit is always a y value. In this case, it was y equals 4. Now, if the question is find the limit of the function as x approaches infinity, then it means that as we go in this direction, what is the graph doing? The graph is approaching y equals 0. Would say 0. If you are given a limit like this, then the first thing to do is just plug in the number. And if you get a real number, then that is your answer. But if you get something like 0 over 0 or a number divided by 0, then we have to do something different. In this case, this is just 6, and so that's the limit. When I do that over here, when I plug in 8, wherever I see x, I'm going to get 0 over 0, so this is not good. What we're going to do in this case is we're going to factor the top and maybe the bottom as well. The top is a quadratic. A is 1, B is negative 14, and C is 48. We need two numbers that multiply to 8 times C, 1 times 48, which is 48, and at the same time add up to the B, which is negative 14. Again, this is 8 times C, and this is B. So negative 8 times negative 6 is going to give me positive 48. Negative 8 plus negative 6 is going to give me negative 14. So the top becomes x minus 8, x minus 6. So that is the top. The bottom, you also have to factor it. The bottom, we have negative 5x plus 40. We have a negative 5 in common, so we end up with x minus 8 inside parentheses. Then we go back. We haven't taken the limit, so this is the limit as x approaches 8 of x minus 8 times x minus 6 divided by negative 5 times x minus 8. Notice how this cancels. So we have the limit as x approaches 8 of x minus 6 over negative 5. And now at this point, try direct substitution. We get negative 2 over 5. Find the derivative of 4x to the 6 plus 8x to the 4 minus 3x minus 6. So let's do it step by step. You have a 4 times 6 times x to the 6 minus 1 plus 8 times 4 times x to the 4 minus 1 and then minus 3. Then once we simplify all of this, we get 24x to the 5th plus 32x to the 3rd minus 3. If you can remember this, it's going to make things a lot easier. The derivative of the square root of x is 1 over 2 the square root of x. The derivative with respect to x of 1 over x to the 9th is negative 9 over x to the 10th. How does this help? It helps because now you go back and you said, oh, the derivative is 6 times 1 over 2 square root of x. Keep in mind that this is the same as 10 times 1 over x to the 9th. So we go back here, we say plus 10 times negative 9 over x to the 10th. Then we simplify 6 times 1 divided by 2, that's a 3 on top over the square root of x. 10 on top times negative 9 on top, that becomes negative 90 on top divided by x to the 10th. If you don't remember these derivatives, then that's okay. Let's go back to the original and rewrite it before we take derivatives. 6 times x to the 1/2 plus 10 times x to the negative 9. This is the original. I just rewrote it. Now let's take the derivative. The derivative is 6 times 1/2 times x to the 1/2 minus 1, which is negative 1/2, plus 10 times negative 9 times x to the negative 9 minus 1 is negative 10. This is 3 over x to the 1/2 minus 90 over x to the 10th. For the first part, the bottom becomes the square root of x, and then this one stays the same. So again, that's another way to find the derivative. On the review, once you do this one, then click on Get Similar Question until you're able to do this without your notes. The graph of the function is shown below. Estimate and list the value of x where the function has horizontal tangent lines. What is a horizontal tangent line? It's this here. So where do we have those? Here I'm coming this way. This is all increasing lines, increasing tangent lines. Over here, at its peak, we have a horizontal. Then all the other points over here, those are decreasing tangent lines. And then at its valley, we have another horizontal tangent. So the x value is x equals negative 2 and also x equals 3. A ball is dropped from a height of 85 meters. Its height exactly t seconds later is given by h of t equals negative 4.9 t squared plus 85. Find the time when the ball hits the ground. This is an up and down parabola. This is the time, this is the height. The initial height is at 85, and then it reaches its maximum, and then it comes back down. Find the time when the ball hits the ground. We are looking at this here. This is when the h is equals to 0 because it's already on the ground. The height is 0. We are going to take that equation and we're going to let it be equal to 0, and we are going to solve for t. To solve for t, I need to subtract 85 on both sides. We get negative 4.9 t squared equals negative 85. Divide both sides by negative 4.9. If we don't get a nice decimal here, you can leave it as a fraction or use at least 4 decimals, 17.3469. T squared. To get rid of the square, we take the square root on both sides, plus or minus. But since we're talking about time and we're talking about this time over here, it's going to be positive, so you can ignore the negative. T equals the square root of 17.3469. That is 4.165, and that is in seconds. So the ball hits the ground at 4.165 seconds. Find the velocity of the ball at any time. The velocity is the first derivative of position. So the given equation, that's the position function. Just take the derivative of that, which is negative 9.8 t. Find the acceleration of the ball at any time t. The acceleration is the derivative of velocity or the second derivative of position. Take the derivative of the velocity function, the one we just found. The acceleration is going to be negative 9.8. Find the velocity of the ball at the instant it hits the ground. So we need to look for the velocity at 4.165 seconds. So just plug it into the velocity function, and that gives us negative 40.817 meters per second. At what speed does the ball hit the ground? Speed is equal to the absolute value of velocity. So in this case, we're looking for the absolute value of the velocity at 4.165 seconds. So we're looking for the absolute value of negative 40.817, which is just 40.817 meters per second. What is the acceleration of the ball as it hits the ground? Look at the acceleration function. That is just a constant. There's no t. So this will never change no matter the value of t. In this case, the acceleration at 4.165 seconds is going to remain the same, negative 9.8 meters per square second. The given function represents the position of a particle traveling along a horizontal line. Distance is measured in feet and time is in seconds. So here we have a polynomial. This is a cubic for t greater than or equal to 0. The first question, it says, find the velocity and the acceleration functions. Velocity is the first derivative. First derivative is negative 4 over 3 times 3 times t to the second plus 2 times 2 times t, and then plus 5. So when we simplify this here, we get negative 4 t squared plus 4t plus 5. Acceleration is the derivative of velocity, so that is negative 8t plus 4. Choose the most correct statement about the motion of the object at t equals 2. So let's find the velocity at 2 and the acceleration at 2 seconds. Plugging 2 into the velocity function, we get -3 feet per second. And when we plug in 2 into the acceleration function, we get -12 feet per square second. In this case, we have the same sign, which means that the object is speeding up. So speeding up, speeding up. Not this one, not that one. The first one, the first option, the object is speeding up because both acceleration and velocity are positive? No. The object is speeding up because both acceleration and velocity are negative. So that is the correct statement. When we introduced derivatives, we had something like y equals e to the third. We know that the derivative of that is 3 times e to the second times the derivative of the inside, but we didn't care about that because the derivative of the inside, the derivative of x, is just a 1. Now, if you have the chain rule like this one, f of x equals parentheses x squared plus 2x plus 7 to the third, just like this one here, but inside the parentheses was just x. Then the derivative is going to be 3 times the inside of the parentheses to the second power times the derivative of the inside. In this case, it matters because the inside is no longer x, it's a function. The derivative is 2x plus 2. And so this is our derivative. The second question is just asking to find the derivative at 3. So wherever you see x in the derivative, plug in 3, and you get 11,616. This question comes from a group of questions, so maybe your number 22 is different from my 22, so please practice the other ones. That way you get more practice on the chain rule. Like this one, this is very similar to the previous one. The derivative is -1 times 5x plus 4 to the -1 minus 1, which is -2, times the derivative of the inside. The derivative of the inside is 5. And so this means -5, because -1 times 5 is -5, over 5x plus 4 to the second power. Because you have a negative exponent, so if you send it to the bottom, it becomes positive. Similar if you have trig functions, remember that the derivative with respect to x of cosine of u equals negative sine of u times du dx times the derivative of the inside. So in this case, we have -4 times cosine of -2x squared minus 5. This is important. This here next to the cosine is a constant. If you have an x instead of a constant, then it becomes the u times v. So please pay attention to those things. If you have a constant in front of the cosine, then just leave it there and then just take the derivative of cosine. But if this here is an x or a function, then you have to apply the product rule. So dy dx is equals to -4 times the derivative of cosine is negative sine of u. I don't change the argument. This is called argument. I don't change it. What I do is I multiply it by the derivative of the argument. And the derivative of -2x squared minus 5 is -4x. All of this has been multiplied. So you have a negative times a negative times a negative. Negative times negative is positive. Positive times a negative is negative. So all of those negatives become a single negative. Then you multiply the constants. The 4 and the 4x become 16x, sign of the argument. Question 26, this is implicit differentiation. Let's start with this. If you find the derivative with respect to x of x, if the variable is matching, if this is matching, then the derivative is just a 1. And we have been doing this whole time. The derivative of x with respect to x is just 1. But if you're looking for the derivative with respect to x of y, then those variables are no longer matching. Therefore, we say this is dy dx. So how does that work? If you have the derivative with respect to x of y to the third, then this means 3y squared times dy dx times the derivative of the inside, which is dy dx. So let's go back over here. Given the equation, find dy dx. We are going to take the derivative with respect to x on the left side and on the right side. On the left side, we have 3 terms, and the first term has an x in it. So the derivative with respect to x of the first term is negative 14 times 3 times x to the second times the derivative of the inside, but that's just a 1. So that's it. The second term, you have to be very careful because this is a u times v. This is u and this is v. And remember that u times v means u prime times v plus u times v prime. So u is 6x to the 70. Its derivative is 6 times 70 times x to the 69 times v, which is y, plus u times the derivative of v. The derivative of y is dy dx. One more time, because this is a u times v, its derivative is this whole thing. The last term, y to the 8th, the derivative of that is 8 times y to the 7 times the derivative of the inside, which is dy dx, equals the derivative of the right side, that's just a constant, so that's 0. The next step is to leave everything with dy dx on the left side and everything else goes to the right. So 6x to the 70 dy dx plus 8y to the 7 dy dx stay on the left side. Everything else goes to the right. By the way, negative 14 times 3, that's negative 42. So it becomes a plus 42 on the right side. And then 6 times 70 is 420. So when we move it to the right, it becomes negative 420 x to the 69 times y. On the left side, we are going to factor out the dy dx, so we get in parentheses 6 x to the 70 plus 8y to the 7 dy dx. The right stays the same. We need the dy dx by itself, so we divide both sides by 6 x to the 70 plus 8y to the 7. Dy dx is equals to the right side. And so this is the derivative. Now find the equation of the tangent line to the curve at 1, 1. Write the answer in the form y equals mx plus b. Whenever it's asking to find the tangent line, the slope is the derivative at the given point. So first we find the slope. The slope is going to be the derivative at 1, 1. So wherever you see x, replace it with 1. wherever you see y, replace it with 1. Simplify, this gives you negative 27. And that is the slope. Now to find the equation, you can use y equals mx plus b. The y is provided for you. The y is this one, the x is this one, and the slope you just found it. So we have 1 equals negative 27 times 1 plus b. 1 equals negative 27 plus b. Plus 27 on both sides. B equals 28. Then you go back to this equation and you say y equals negative 27x plus 28. We need to be able to identify when the function is going to use the product rule and when the function requires you to use the quotient rule. So in this case, it's asking for the derivative of g of x. And g of x is e to the x over 1 plus 2x. This is a u over v. So the derivative is the derivative of the top. The derivative of e to the x is just e to the x times the bottom minus the top times the derivative of the bottom, which is just 2, divided by the bottom to the second power. This is the derivative. I mean, you can leave it like this. If you simplify, let's factor out the e to the x. So if we factor out e to the x, we're left with 1 plus 2x minus 2 divided by the bottom square. The 1 minus the 2, that reduces to negative 1. So we get e to the x times negative 1 plus 2x over the bottom square. In your formulas, you will find the derivative with respect to x of log base a of u, which is 1 over u times ln of a times the derivative of u. So for this one, you have the derivative with respect to x of log base 6 of x. That is equals to 1 over x times ln of 6 times the derivative of the argument. But the argument is just x, so that's just a 1. So that doesn't matter, you can just ignore it. For the second term, the derivative with respect to x of the 8th root of x, the 8th root of x means x to the 1 over 8 is equals to 1 over 8 x to the 1 over 8 minus 1, which is 1 over 8 times x to the negative 7 over 8. And then for the last one, the derivative with respect to x of e to the x, that is just e to the x. So when we put this together, we have 9 over x ln of 6 plus 1 over 8 times x to the negative 7 over 8 plus 2 e to the x.